Well, hi, good morning. Thank you so much for joining me here in my shop on March 29th, almost the end of March. Oh my gosh, I got this very nice looking little radio here, clock radio obviously. Don't know how this is going to go, of course. Don't know really anything about this. But I do know that clocks this old generally don't operate. So one thing about this radio is the plastic protective dome on the front. It's just ready to fall off. So it looks like the tabs have been broken here. I'm going to guess by somebody trying to pry it off for some reason, but who knows. So there we are. CBS Columbia. Isn't that what CBS stands for? Columbia Broadcasting System. CBS radio. Internal antenna connection. Model number, there's the model number. Model number 5330. Cycles, it only lists 25 cycles here. This radio is that old? I mean, that puts it back into the 1950s. A couple of penciled notes on it. 1698, I believe that says Gerrard. Now that's interesting. Gerrard is the name of a road in Toronto. And I used to live at 96 Gerrard Street, which would be quite a few blocks from 1698. But yeah, right downtown Toronto. If you know Toronto, I used to live right near Maple Leaf Gardens. Oh, I lived in a number of locations. Like Canadians move a lot. Apparently at one time anyway, maybe it's still true, more than anybody else, any other people in the world. So we got two speaker grills. No, this one's a fake. This is the tuning, and what has happened to that? You see the kind of a weird goo, or so maybe there was something glued in here at one time, like a gold cover, like that. There's a brass or a gold, hardly gold anymore, but a brassy colored cap here, which is missing off of this side, but it doesn't make that much difference, does it really? So there's the dial markings are here. Well, but I don't think I want to just plug this straight in. Nobody's written any notes on it. I have no idea of the condition of it, so let's find out. Take a look inside here. It's got Canadian style screws. It was almost certainly made here in Canada. Manufactured by Addison Industries Limited. And the name of the location, licensed by Canadian Radio Patents. So that is going back. This is older than it looks. So when you look at the style of the numbers on the front, yeah, it doesn't really give anything away, does it? Okay, so I've taken the back screws off. Maybe I shouldn't have done that. I probably should not have done that. Yeah, that's a mistake. So I can put those screws back in without really not thinking hard. A lot of these radios have the antenna mounted on the back, like this one. And the back is mounted to the chassis. It's really meant to stay on there. I should not have taken these off. So a lot of these older radios have the antenna mounted on the back, and some of the radios the back is lost, the back is gone. And if you get a radio like that, it's not obvious that the antenna is missing. But without the loop antenna on the back, the radio's reception would be greatly degraded. This looks like green. So these Canadian screwdrivers I'm using, they come in, sorry about that, they come in 4 sizes. Yellow, green, red, and black. Black is the big one, yellow is the small one. There are 4 sizes of these screwdrivers. imagine there's some other countries that have adopted this kind of screw. Okay, so we gotta take these knobs off. Oh, just not much holding that on. This one's a little better. Okay. Clock and all is going to come out. There we have it. A little dirtier on the inside than the outside. The last radio I did was one big dust bunny. This is not too bad. Okay, so 1, 2, 3, 4, 5 tubes. No surprise there. Tuning capacitor tucked down here. Clock sitting there. I think that's paper right on the front. It looks to be in okay shape from what I can see. All the tubes are in place. The antenna wire is not broken off. Speakers there, everything's there. And we look underneath. Let's look underneath. Here we go. What have you been doing, Mr. Radio? Well, it's all original underneath. This guy's probably a bad actor. And these ones could be bad too, but they look to be in good shape. There's a confusing about just what the age of this is, because it has this part here, which is like an integrated circuit, a very, very early integrated circuit, integrating, and I'm using the word a little loose, integrating some capacitors and resistors into one device. Problem with these, if you have trouble in them, it can be trouble dealing with the trouble. This looks like it's been replaced because the band here, two things. One, it's bent funny. I think this is physically smaller than the original, which is probably just a little bit bigger on here. So this is a replacement, so maybe we're in luck. 40 and a another one down. 2 40s. It's a 40 and a 40. Now I think I heard my cat behind me. Oh yeah, he's there. Now when you look at the when you look at these plates, you see the outside plates on both the antenna tuner and the local oscillator tuner. They've been bent out slightly. So someone has made an adjustment here, no doubt in the factory, to compensate for problems in the wow, this has just got a tuning wheel. I mean, how concerned can you be? But anyway, I'm pretty sure that's why these plates are bent slightly open on the outside. Okay, I think I got to deal with my cat here because oh, there he goes. He thought I was on my way out. He took off. Hey, Peanut. Peanut. No, something's got his attention. He does respond when I call him. Sometimes, when he feels like it. Okay, I'm going to stop for a little bit, think about turning this on. I'm pretty sure I'm going to plug it in and give her a shot, see what it does right away. Okay, well, I think if I plug this in, turn the power on without turning on the actual radio, the clock should come on, of course. And we'll find out right away if the clock works. So, on, off, auto. It would be on, off, auto. Okay, so I'm going to turn this off. And I think we're okay. Now, this is the first of my videos you've ever watched. I have taken steps here to keep myself safe doing this kind of stuff. Part of it is plugging in something like this. I'm using an isolation transformer, so there's no ground reference here. And I'm also putting it through a couple of light bulbs, this light bulb here, to restrict the amount of power in case there's a big fault in here. So it may not look like it, I may not be talking about it, but there are things going on here to keep me safe. Here we go. I hear the clock. I see the clock. Oh my gosh, this clock works. Well, that's a big surprise right there. Let's see if I can turn the hands a little bit. Well, that's the alarm setting, or the on-off setting, and then I got to pull this out, and I'm having a hard time moving this. So what I'm trying to do here, aside from knocking my camera over, is turn this. This is missing its little knob. It's just about impossible to turn. Well, we'll leave it like this. We'll just assume that if this can move, the whole mechanism is turning inside. So, clock, not a problem. Now, what about the radio? Do we dare turn it on? Sure. Okay, so I'm going to turn the power off up above. Power's on. Flip it on like this. Now I'm going to hit the power. Once again, the power is going to go through the light bulb. It's going to be a little more this time, so the light bulb may glow. What I'm hoping to see is the light bulb glows bright and then dulls down and then comes up again. And at that time, the speaker starts producing sound. What's probably going to happen? A big whopping hum. You know, where did the volume control go? Oh, it's hidden. I can hardly see it down here. It's hidden away. Okay, eyes upon the light. Bright. Should be going down. Going down. It's hard to tell in the camera. The camera doesn't... I can see the actual filament quite clearly with my eyes, but it's too much for the camera. Yep, it's going down in brightness. It's very low voltage being fed to the radio. Only 56 volts, 57 volts. Take a while, but the heaters will heat up, the rectifier will rectify, the tubes will begin to conduct. Sound should come out. I never checked the volume level here. Ooh, it's turned right up. That could have been surprising. Well, okay, so I'm looking to make sure I'm seeing the heaters in these tubes. Oh, I can hear the hum starting. It's just taking a very long time because we're only operating at like half its normal voltage here. Surprising it works at all. So even at this voltage level, what do we hear? We hear a big hum. But I think I can hear the radio in the background there. Let's tune it a bit. No. There's no radioing going on. It's a nice warm hum. Okay, so it may not be working because it's still being fed with 60 volts. So I'm going to raise the voltage here. It's going to be almost full voltage. I'm going to do it by screwing in a second series light bulb here. This bulb would be in parallel with this bulb, but the two bulbs are in series with the radio. So, but this will raise it up to almost regular voltage. Let's see what the radio does. It's 100 volts. That should be enough. Okay, turning it up. It would appear to not work. Let's give it a bit more time here. The volume control appears to do nothing. You hear some sounds coming out of the speaker, kind of the crackly stuff. Doesn't seem to change if I tune. I think we can conclude the radio does not work. Okay, step one is going to be testing the tubes in here, even though they're all lit. There could still be a defective or terribly weak tube. So I think that's really the next step here. Tube testing. Okay, I've got to let those cool off a little bit, and then I'll test them. Okay, let's start with the rectifier tube. Even though we could hear some sound coming out of the speaker, I mean, that's pretty good Pretty good indication this tube's good. 35W4. Good, because I've set up my tube tester for 35W4 already. Okay, let me just turn on an extra microphone here. Okay, here we go. 35W4. There's two tests for this tube. The first test is looking for what they call a ballast on here. Ballast effect. Oh. Hold on. I was right. Ooh, jumpy. Yeah, so on a tube tester, you have a control over the filament voltage. And the last tube you tested is usually where this is set. And I had this set to 35, which is good because that's a 35. Lucky me. For some reason I didn't set it. Let's just check the rest of the settings now that I've shown myself to be goofy. JR 03670. 03670. I set these before. Okay, so what we should find here is a short during the short test on every one of these settings. The short be indicated by the light here. Here we go. Hey, what's going on with 2? Remember, short on 1, 2, 3, 4, and 5, but no short. Now maybe it's a tube socket thing. No. Wow, is that a bad tube? No short on 2. I don't know about that. That seems a little odd to me. Okay, now we're going to do the next test. Carry on. Oh, you know what? It was done wrong. This was done wrong. This test was done wrong. I did the test wrong. That's what's going on here. That's why I had this. This should be set to ballast. BLST dot. Okay, let's try this again. I don't ever remember doing this on this tube, this type of tube. Here we go again. Set the ballast. Do we get shorts everywhere now? No, we don't. We still get, now we got 2 missing. Well, no, 3 is there, 4 is there, 5 is there. Tain't no 2. Kind of odd, eh? Again, just making sure it's not this. What to make of that? Wow, okay, a little bit of a confusing test to start off with, but what do we do about that? We stick another one in there. I'm going to get another 35W4. We're going to test it. You kind of have to wonder when you get a test like this, is it the tube tester or the tube? So we'll set that one aside. We've got a few of them here. Let's see what this is. 35W4. Just look more closely. 35W4A. Don't think that's going to make any difference. So 35W4, we go right in. Moment. I'm not sure there's any when it's on ballast here. I doubt the tube is heating up. Yeah, there's no heat in the tube, so let's go ahead. Oh, what happened? What's going on here? This isn't the 35W4. Did I not see it correctly? It's an A. I wonder if that's the difference. 35W4A. Wow, okay, things are getting stranger. Not less strange. Getting stranger. Let's try another one. How about this one here? 35W4. is not a W4A. Okay, nothing to heat up. Where do we go? Once again, number 2, no show. So I'm going to conclude that either number 2 shouldn't show a light, or my tester wire is broken under there or something of that sort. So we're going to go back to the original one. Actually, I'm going to reset now to do the next test on here. Oh, yeah, that's the original one. I hope I didn't mix them up. Probably mixed them up. Let's find out. We can find out right here. Because the light comes on. Okay, good. So that's the original one in there. Now there's this second test, a real test of the tube itself. So now we set it to 35 volts. JR0507. JR0507. 0. Bias is 0. English 55. That's where it is. P3. P3 is this rectifier button. Rectifiers, need this on English. Push the button and it's replacer good. Okay, there's no value. Since there's no grid in a rectifier tube, there's no transconductance. There's no transconductance. I guess that's what I would say. Give it a moment to warm up. Do we do the short test? I think so. In this case, the light should not stay on. Very good. So we're going to push P3, and we hope it comes up in the good. Oh, it's in the good. Okay, so this is not a problem at all. In fact, it's in pretty good shape. Now, the next most likely tube to have trouble would be the output tube. Tube is the other tall tube. It's tall because it's conducting a lot of current, it's working hard, it's getting hot. All those reasons. And it is a 50 C5 as expected. Okay, let's take a look. 50 C5. And you watch the whole process here. 50 C5. 50, I'm looking right here. 50 C5. 50 volts. JR 2763. 2763 0 23 91 on the English, and the actual value is supposed to be between 4700 is a failure, 7500 is the normal. So I'm going to put this on the scale, on the 6000 scale here. And it's a really good tube, it's going to go right off scale. Okay, we'll double check. 50 C5, 50 volts. JR 2763 2763 0 2391. 2391. The 91 doesn't even matter unless we're going to utilize this English setting, and then we just use the replace good thing. But I'm just a little smarter than that, so I'm looking at the numbers, the actual numbers. Okay, let's look for shorts in the tube first. No shorts being reported, although now I gotta wonder about position number 2. Okay, so in this setting, 4700 is about here. So this tube has to test above my finger, or the tube tester is suggesting we throw it away. There we go. Now see it sinking? Can you see the pointer is sinking? And it's sunk below. It's at 4000 now. This tube is very weak. I think we could call it very weak, but it works. So you'd still think there should be some output. Where's the fuse coming up? guess that's drawing a fair bit of current when I'm doing that. Okay, I don't think this would explain why the radio is silent. This might explain why you have to turn the volume up. Okay, let's go work our way from the speaker back. So the next one is the detector tube and audio preamp. Looks like an AV. 12 AV6. Okay, back over we go. 12 AV6. Let's change it. So I didn't really finish my discussion. When you test a tube like a 50 C5, you leave this up on 50 and forget. And you come along with your 6 or 12 volt tube, plug it in, you got 50 volts on it. So the good practice is to return this down to 6 or below every time you finish using it. Of course, I don't do that. Okay, 12 AV6 for sure. 12 AV6. 12 AV6, there it is. 3 tests on this tube. 12.6 JR 3702 with a 5. 3702 with a 5 on the end. 12. 58. So first we're testing the triode section. So this tube is actually, you can think of it almost as just 3 tubes in one, or kind of 2 tubes in one. One is a triode amplifier. That's going to take the audio signal out of the radio circuits, pump it up and send it over to the output tube. And then the other part of this tube, which has nothing to do with that, are the actual diodes that do the rectification of the output of the IF circuit and actually uncover the audio. There we go. Ready? We're ready. There's 2 diodes in there. This radio may use one or both. Just depends what the design engineer thought was best. Probably through experimentation. Okay, any shorts in this tube? There we go. Any short? No shorts. Yeah, flashing is fine. Flashing is good, actually. So now we should be coming up to 790. So I'm on the 3000 scale now. So 790 is way down here. Way down here. So all you got to do is get up above that. Can you do it? Oh! This is the killer. This is the tube that's killing. Now, why so weak? Maybe I made a mistake. Let's double check. Although I never make mistakes, we should check. 37025. 37025. 12. Very important. 58. Not important. Well, that's all there is to it. And 12.6. We'll try again. Oh, she's weak as can be. Let me put it on the English setting. Now the 58 is important. The 58 is controlling the... What does this say? Replace this guy right away. Hurry. Okay. So what has happened to this tube? So probably what has happened is the cathode is worn out. Now, I think the cathode is shared with the diodes. So let's see what the diodes do in here. I'll set this up for one of the diodes. Okay, 3602 with a 5. 3602 with a 5. 00. P1. Put this on English. Press P1. That's the diode test. Okay, put it back in. Let that warm up. But this is weak enough to kill the radio output. I think it's weak enough. I suppose it might still be sending a little bit of an amplified signal on, but it's just not enough to break through the very low level noise that's there, I think. We didn't hear any hint of operation out of this, so maybe there's still another tube, or maybe there's a series of dead tubes, or weak tubes, I should say. Okay, so we're ready to do this test. A diode, so a diode has to pass, I don't know if you can read it there? There's a little bit written here under my finger. It says diodes okay past this point. Excuse me, push the diode button. So that's testing okay. Maybe that's the diode that's never been used. I don't know. Let's test the other one. 60. So we change 6 to 5 and 5 to 6. And everything else stays the same. P1. Oh, it doesn't make it up to diodes okay. Yeah, that's a bad guy. He's a bad guy. I don't think he's going back in the radio. Next one. Next tube is the, I'm sure is the IF amplifier tube. It's probably a 12BA6. Can't see that. BA6. You want to be very careful you don't have the wrong tube. People pull tubes out, they swap them around, they stick them back in, you know, stuff happens like that. Not here though. 12BA6. 12BA6. 12BA. Too far here. Oh my gosh, it's way. So 12 BA. What is my problem here? There we are. I don't know why I kept going by. 12.6 JR 3567 with the 2. 3, 5, 6, 7 with a 2 on the end. 9 and 83. 9 on the bias. 83 on the English. Should we choose to use it? 2,000. Throw it away. 3,000. You're happy. So 2,000. Throw it away. That's what that's set for. Very common tube. 12 BA6. So this tube's job is to amplify the IF signal, the 455 kilohertz signal. Usually physically sits between the two IF cans in a radio, which makes sense. Geographic sense, I guess. Okay, let's see. Any shorts in this tube? This is barely flashing. So this is already a sign that the tube is weak. So I believe what's happening when you move this control, and there isn't a short and you see the flashes, you're discharging charges that have built up somewhere. Seems to me strong tubes, those charges don't dissipate. Weak tubes, they get really weak. Let's find out. This is a radio of weak tubes. Right, 2,000. Can you make it? Okay, hang on. Could be tube contact here. Oh my gosh. That is dead. That's unusual. Let's just double check this. First of all, yes, the heater is glowing. Did I do this right? JR3567. JR3. I've got a mistake right there. Now this tube tester, you can change these settings while the tube is sitting in there. Nothing is applied to the tube to push one of the test buttons. Not all tube testers are like that. 35672. Let's 35672. 9. Okay, we're ready again. Any shorts? Now we're getting stronger flashes here. That's a better sign. And now we'll push. 2,000 was here. Oh, we're right over. Look at that. It went from terrible to excellent. Tube testing. Okay, I'm going to stick that back in the radio. Now the next tube, this is the last tube to test. So if there is a tube that's choking the radio to death, it's got to be this guy. Although I think the AV tube, I'm pretty sure is 12BE6, that's correct. You'll find these radios all contain pretty much the same set of tubes. So 2 tests in a 12BE6. 12.6 JR 75623. 7 5 6 2 3 11 63. Amplifier section. So this tube has well, let me get to it. Let's just test it. 12B6. Okay, in you go. Yeah, this tube is doing two jobs in the radio, and boosting the signal coming through the antenna. But more than that, it's mixing that signal with the local oscillator inside here and coming up with the IF product, if I can put it that way. Okay, here we go. What do you say, Mr. Tube? Okay, some flashing there. So this should come up to 900. This has to pass 900 to be considered good. 900 is there. Huh, okay. That's pretty good. Now we'll do the next test on the same tube. So 3562 with a 7. 3562 with a 7. Bias at 0. It's a little unusual. 67. Press P4. This is the oscillator section. It should come up to about 1,000 right about here. If it's good. Let's check for shorts, just because it's a good thing to do. A shorted tube in a tube tester can damage the tube tester. Here we go. Can you make it to 1,000? Right over. Okay, so this tube's not causing a problem. It cannot be responsible for a dead radio. Okay, I'll stick this one back. I will find a new, or a good 12 AV6. We'll stick it in there and see if that makes the difference. Great. Okay, let's see if I've got a good, I'm sure I do, a gooder 12 AV6. Here we go. Just want to double check it. 12 AV6. 12. So I think this, this is potentially the killer tube that was killing the radio's operation, although there could be many other things wrong in the radio. But this will eliminate that possibility. We put this tube in. This is not going so well here. 86. This should come up to 790, about 800. So about here, 3,000 scale. Yeah, it's a weak one. Okay, we don't want to use a weak one. We want to use a strong one. How about this one? 12 AV6. I wrote it on 2 lines. Give it a moment. So today, unfortunately, we're expecting snow. Oh my gosh, really? Yeah, heavy snow for a couple hours. The temperature's right around freezing, so I don't think it's going to hang around. Okay, once again, making absolutely sure here. 800. Oh. Well, it gets there. Now, if this was a really good tube, it would be 1250, and 1250 is up. No, it's only about there. Let's push the button again. About halfway. Now there's another section on this tube. The diode section. 3602 with a 5. 602 5 0 0. Press P1. So it's up above diode's okay by a long shot. And then there's one more test. 3502 with a 6. So 6 becomes 5, 5 becomes 6. Until we're swapping the pins around. P1. which is a good one. So a little weak on the amplifier, but strong and good on the diodes. Let's stick this guy in and see what we get. See if this is enough to make the radio work. Now, you gotta bear in mind it's humming. If the hum is really bad, you can't hear the radio operate through it. Seemed to be a semi-bad hum. Semi-bad. Oops. There we go. Okay, volume down. Yep. And we're going to go power through two dim lights here at the same time. Should provide lots of power, lots of voltage rather, 100 volts. I hear the clock turning, that's what I hear. Okay, Mr. Radio. Oh, there it comes. Sounds like it's working. Improve the contact here. So I got one tube that was silent. That's a little odd. I expect every tube to make a little bit of a crackly sound. Okay, radio, are you working? Volume down, volume up. Where'd the horrible hum go? How do you like that? Let's see what we can pick up. Notice something here. On the side of the radio is obviously a coil that's supposed to be slug tuned, and there should be a threaded piece sticking out here. And where'd that threaded piece go? Let's see if we can find it. Is it in there? I don't see it now. It's fallen way in. What's happened here? Or is there no threaded piece? I don't think there's anything in there. No? Maybe it's just a coil, or oops, maybe the threaded piece is just turn the volume down. Maybe the threaded piece is on the inside. Well, there's no... This typically doesn't have a slug, this kind of coil. The radio's reception's going up and down because I'm getting close to the antenna. And let's check it out. It's working pretty good already. So when I hear all that swooshing and interference, and I think that's a sign of the radio not operating properly. Let's compare another radio. Kind of an unfair comparison. We'll tune the same stuff.
Where now toward it his photo and his name.
So you can still hear the tone in here, the pitch. It's very quiet though. Tone control is set to... Oh, don't set high even. So a little bit narrower bandwidth in this radio. It's hearing more of the station and less of the noise around it, I think. What is the focal point? So you can hear the treble. A lot more treble in this radio. I'm gathering it's just swallowing a bunch more junk. I gotta take this radio to another location in my house and see what it sounds like. I'll report back. Okay, well in fact I took the radio to another spot in my house and it actually sounded pretty much the same. So I think, but I could hear the hum coming from it a little bit clearer than I heard it in here. So I think we really do need to deal with this capacitor here. Rest of it, I'm inclined to leave it alone at this point. Let's change out this big capacitor here. We'll put a couple new ones in and we'll eliminate the hum and we'll see what happens, because sometimes these capacitors, as much as they're in the power supply to control hum, they also do a couple other things. One of them is, how do I explain it, creating a signal ground or a path for signals to reach the B minus line through them, but they're not very good at high frequencies. So I think maybe as these things get weaker, they don't resolve or snuff out or ground out or whatever the word should be. Bypass, I guess, is the right word. The signals to ground that might need to be bypassed. So anyway, I'll change this and we'll see if the behavior of the radio changes too. Okay, well, lots of time has gone by. I've been out grocery shopping and other stuff too, but didn't really show it. What's this one? So I had replaced the capacitor. Those two there. And we're going to give this guy a try. Turn the volume down. Radio's on. Plugged in. Ready on the dim bulbs. I just freaked myself out. Turn it on and I can hear and it sounds like something frying in there right away. It's the motor to the clock. At least that's what I think I'm hearing. Tubes are lighting up. We're running it with 105 volts. Turn it up. Not yet. Okay. Where did our station go? There we are. So that's 590. And this dial 590 is just above my finger here. And there's no... There is a mark. There's a mark here, but you see it's not actually level. It's kind of up where you'd look down at it. So, right on. Just right on. Very good. Okay, now I'm going to break all the rules of radio repair. Just by listening to that, I'm going to check for maladjustment first in the IF. Just a sec here. Put a flag on my screwdriver. It's very shrill, the sound in this radio. Okay, so I put a flag on my screwdriver so I can return this to exactly where it came from. Not that I plan to turn it very far. This doesn't feel good. Screwdriver too small. Fit in. Okay, is that a screwdriver effect? Let me pull it out and just listen. Yeah. Let's try this little screwdriver. Blade is too small. Why don't we try a proper tool? Hey, there's an idea. Look, I got one with a flag on it. There's not much play in the not much. Look at that. When I was a teenager, my friend had a 1960 Ford Galaxy 500, and there was almost a half a turn of play in the steering wheel. I'm not kidding you. It was crazy. It was a crazy car to drive. Okay, let's try another tool here. Too big to fit. Perfect. This one has a bit of a wider blade on it. Even though it's plastic, it's thick and very stiff. So this is actually a very good tool. Okay, all we want to do is find out, does it get better or worse? Where's my flag? I need a flag. If it gets better, then that means it's not aligned as well as it could be. Very crude way of doing it. Okay. Anybody hear any difference? I didn't hear any difference. I think I'm tightening the, I imagine that I'm tightening the response. It's very seldom that I adjust the IF with the radio actually playing a station. It's something I usually do with equipment, and so I'm curious about. Plus, I know if I mess this up pretty badly, then I'm just going to put some test equipment on it and sort it out. There's 2 more of these. That was great. Don't grab the tuning knob, Jim. Here. Here we are. That was bad. Now I don't know what frequency I'm aligning this to. Could be aligned to the wrong frequency. But that's okay right now. Not recommended to do what I'm doing, but I know like as I mentioned, I've got the instruments. If I mess this way up, I can always correct it. Now we'll try the antenna here. Metal screwdriver. The antenna will be the antenna adjustment, the larger set of plates. Stay away from the oscillator. Here we are. I think that's probably good enough for this guy. Now the whine you hear and the pitch and all that, that's not the radio, that's what it's receiving here. Put this in a different location, it's going to work quite well. I'm quite happy with that. It's just fine the way it is. And look what time it is. No, it's actually 2 o'clock in the afternoon. So great. Well, I'm going to put it back in its cabinet. We'll take a last look at it. Okay, time to give it a go. Oh, this cabinet has cleaned up just like new. It's really nice. Fantastic, actually. Okay, I even found a knob here, although it's not the right knob. It's going to do the trick. There we go. Apply the power. I believe the radio is turned off. Really nice. It's very attractive. Clock works. Fantastic. Even got the writing here even. Kind of adds a little bit to it. Very nice. Okay, let's see if it works. The volume's turned down. Whoops. Yeah, this plastic piece is a problem. But I'm not going to try to solve it. The next person who owns it, if you leave it alone, it stays on. You just get smart enough to put your thumb here. I think I just turned it on. Whoops. Ah, there we go. Good show. Tension mounts. It's not turned on. I think it's on now. That's too bad. The tabs are broken off, and it's not a simple thing. I mean, you could put some tape in here or something like that. There we go. It's just a coincidence. It's tuned in.
And it's not been Panther goaltending. It's been up against amazing goaltending position. And the Panthers, most of the time, they lead in shots, they lead in scoring chances, they lead in odd man rushes for and not yet.
The stations.
They just can't put the puck in that.
I'll have to put a little tape in here. So there's a noise signal right next to where the station is. And if you tune the radio, like that, let's say that's a signal, that's the noise. If you tune the radio right on the station, you hear the noise. But you can afford to tune it a little ways off and still listen to the station. And at the same time, you can depress the noise. You just tune a little left or right, if it's this kind of noise.
And they've got the chances, and their chances off jumping in, and then all of a sudden they'll go on a wall. And
sounds like there's two in there. Okay, let's go. That's not too bad. That's the French station I like to judge radios with. That's pretty good. Hum-free. Clock works. Can't beat it. That's fantastic. Well, thanks a lot for watching. And, I went out grocery shopping twice while I was working on this radio. One time in a snowstorm. We had a snowstorm today. Hey, it's been a crazy day. But the radio came out okay. Thanks a lot for watching. See ya.